The afternoon sun beat down on the gleaming headquarters of Quantum Dynamics as Thomas Marshall stared at the failed engine prototype, his reflection distorted in its metallic surface. As the first black CEO of a major engineering firm in the Yastar country, Thomas had faced countless challenges, but none quite like this. The revolutionary engine that promised to cut carbon emissions by 70%, the cornerstone of their $200 million government contract, had hit a wall. "Run the test again," Thomas said, his voice calm despite the tension filling the lab. Dr. Chen, the head engineer, shook her head. "We've run it 17 times with the same result. The core overheats after 9 minutes of operation. We've tried everything." Thomas removed his suit jacket and rolled up his sleeves. At 57, he still carried himself with the energy of someone decades younger. "The Department of Energy inspection is in 3 weeks. If we don't have this working, we lose the contract." The room fell silent. Everyone knew what that meant. Layoffs, possibly the end of the company Thomas had built from the ground up over 20 years. "Maybe we should consider delaying the inspection," suggested Robert from the board. He had always been the cautious one. Thomas shook his head. "That's not an option. Our competitors are 6 months behind us. If we delay, they catch up, and everything we've worked for goes down the drain." As the engineering team packed up for the day, defeat hanging heavy in the air, Thomas stayed behind. His mind drifted back 30 years to when he was a young engineer with big ideas but no connections. Harold Williams, the old head of R&D at General Motors, had given him a chance when nobody else would. "Sometimes the answer comes from where you least expect it," Harold had told him. The memory gave Thomas an idea. Instead of heading back to his office, he decided to walk through the production floor, something he hadn't done in months. The main factory was winding down for the day. The steady hum of machines gave way to the sounds of workers gathering their things, laughing and chatting about evening plans. Thomas nodded and greeted people as he passed, many surprised to see the CEO on the floor. Near the back of the facility, he spotted Mike Reynolds, one of their longest-serving machine operators. Mike was hunched over a workbench with a young woman who looked to be in her late teens. They were examining what looked like engine schematics during their break. Curious, Thomas approached. "Evening, Mike." Mike looked up surprised. "Mr. Marshall, didn't expect to see you down here today." "Just taking a walk." "What are you looking at?" Thomas gestured to the papers spread across the table. Mike hesitated. "Oh, just showing my daughter some of what we do. She's always been interested in how things work." He quickly gathered the papers. "Hope that's okay? These are just the public schematics from last year's model." Thomas smiled at the young woman. "You're interested in engines?" She met his gaze with surprising confidence. "Yes, sir. I'm Zoe. I've been helping my dad fix things since I was little." She pointed to one of the diagrams. "I was actually asking him about this cooling system. It seems like there's a flow restriction that might cause problems when it heats up." Thomas froze. He glanced down at the schematic, an older version of the very engine they were struggling with now. The cooling system had been modified since, but the core principles remained the same. "How did you notice that?" Thomas asked, trying to keep his voice casual. Zoe shrugged. "My grandpa ran a repair shop for farm equipment back home. Heat flow was always the biggest problem with engines working long hours. This reminds me of a tractor design that used to overheat when pushing too hard." Mike looked embarrassed. "I'm sorry, Mr. Marshall. She gets carried away with this stuff." No. Thomas waved him off, studying Zoe more carefully. "How old are you, Zoe?" 17, sir. Senior year. I'm hoping to study mechanical engineering next fall if I can get a scholarship." Thomas felt a familiar spark, the same one he'd experienced when he first conceptualized the engine design that put Quantum Dynamics on the map. He pulled up a chair. "Tell me more about this flow restriction you noticed." For the next 20 minutes, Zoe walked through her thoughts, using simple terms but displaying an intuitive understanding of thermodynamics that stunned Thomas. She had no formal training, just years of hands-on experience helping her father and grandfather fix things. As the janitor began turning off lights in sections of the factory, Thomas made a decision. "Mike, could you and Zoe come to my office tomorrow morning? Say 9 a.m.? Mike looked confused. Did I do something wrong sharing those old diagrams? Not at all, Thomas assured him. I just want to continue this conversation and maybe show Zoe our newest project. That night, Thomas barely slept. He paced his home office, making notes and thinking about Harold Williams. The old man had spotted something in Thomas that others missed. Not just engineering talent, but a different way of seeing problems. What if Zoe had that same gift? By dawn, Thomas had made up his mind. When his executive team arrived for their 8 a.m. crisis meeting, he was already there with a proposal that made them all stare in disbelief. You want to show our proprietary technology to the teenage daughter of a machine operator? Robert asked, his voice rising. Thomas, with all due respect, we're talking about a $200 million contract. This isn't take your kid to work day, Dr. E. Chen was more measured. What makes you think she might spot something we missed? We have PhDs who've been working on this for months. Thomas leaned forward. When I was Zoe's age, I fixed my neighbor's car when 3 professional mechanics couldn't figure out what was wrong. Not because I was smarter, because I looked at it differently. He stood up and walked to the window overlooking the city. We've tried the conventional approach. We've hit a wall. What do we have to lose? The silence in the room said everything. They were out of options. If this gets out, to the press, the PR director began. Then we control the narrative, Thomas cut in. Look, I'm not suggesting we hand her the keys to the kingdom. I'm saying we give her a controlled look, a fresh perspective. Just then, Thomas's assistant knocked on the door. Mr. Marshall, Mike Reynolds and his daughter are here. The executive team exchanged glances. This was actually happening. Send them in, Thomas said, feeling a strange mix of doubt and hope. Was he making a huge mistake or about to witness something remarkable? Either way, the clock was ticking on quantum dynamics' future, and Thomas Marshall had always been a man willing to take the road less traveled. As Zoe walked into the room, her eyes widening at the executive suite, Thomas saw something in her expression. The same hunger for knowledge, the same fearlessness he once had. Whether she could help them or not remained to be seen, but one thing was certain. Today would not be business as usual. The tension in the executive boardroom was thick enough to cut with a knife. Zoe stood near the doorway next to her father, Mike, clearly aware she had walked into something important. The executive team's expressions ranged from curiosity to outright disapproval. Thomas walked over to greet them. Thanks for coming, please have a seat. Mike looked uncomfortable in his work clothes amid the suits and silk ties. Mr. Marshall, I'm not sure what this is about, but if it's about the schematics yesterday, it's nothing like that, Thomas assured him, guiding them to chairs at the massive oak table. Actually, I wanted to talk to Zoe about her observations. Robert cleared his throat loudly. Thomas, perhaps we should discuss this privately first. Thomas ignored him. Zoe, what do you know about our new emission reduction engine project? She sat up straighter. Just what's been in the news. It's supposed to cut pollution by 70% while maintaining power output. The government's considering it for mass implementation. She hesitated. Is that what those blueprints were for yesterday? The cooling system looked similar. Thomas nodded. A previous version, yes. We're having an issue with our current prototype. It overheats under full load. Thomas, Dr. Chen hissed, and that's proprietary information. Thomas held up a hand. Zoe, what would you do if you were trying to solve an overheating problem in an engine with restricted space for cooling channels? Without missing a beat, Zoe replied, I'd look at the material first. Heat dissipation isn't just about airflow, it's about what you're trying to cool. Different metals conduct heat differently. She glanced around, suddenly self-conscious. At least that's what my grandpa always said. The finance director scoffed. We're supposed to take mechanical advice from a teenager quoting her grandfather? Mike stiffened, but Thomas leaned forward, intrigued. Go on, Zoe. Well, when we fixed Mr. Patel's old tractor last summer, we couldn't figure out why it kept overheating. Turned out the previous repair guy had used the wrong alloy for a replacement part. It looked the same, but conducted heat all wrong. She shrugged. Simple fix once we spotted it. Thomas looked at Dr. Chen, whose expression had shifted from irritation to slight interest. We've checked all materials, Dr. Chen said, but her tone had softened. Everything is to specification. Sometimes specifications are wrong, Zoe said, then immediately looked down. Sorry, I didn't mean to sound rude. Thomas smiled. No, you're right. Specifications can be wrong. He turned to the executive team. I want to show Zoe the engine. The room erupted. Absolutely not. Have you lost your mind? What about our NDAs? The liability alone. Thomas let them vent for a minute before raising his hand. The room quieted. I understand your concerns, but we're stuck. We've tried everything by the book, and we're out of time. He looked at Mike. I assume Zoe has fixed things around your house. Mike nodded slowly. Since she was 9. Started with a broken toaster. Last month she rebuilt our entire heating system when it died. Saved us thousands. And does she have formal training? Thomas asked. No, sir. Just what she's picked up from me and her grandpa. And YouTube, I guess. Mike smiled slightly. She's got a gift, though. Sees things differently. Thomas turned back to the team. That's exactly what we need right now, someone who sees things differently. Dr. Chen still looked skeptical. And if she can't help? We've wasted precious time. And if she can, Thomas countered, we're running out of options. Robert stood up, straightening his tie. This is absurd. I won't be part of this circus. He headed for the door. Call me when you're ready to be serious about saving this company. After he left, the room fell silent. Thomas looked at Zoe, who seemed unfazed by the outburst. Are you willing to take a look at our engine, Zoe? Just to give us your thoughts? She glanced at her father, who gave a small nod. Yes, sir, I'd like that. She's supposed to be in school, Mike pointed out. We can arrange for her to make up the work, Thomas said. This is educational too, right? Zoe's eyes lit up. Very educational. 20 minutes later, they stood in the high-security lab where the prototype engine sat in a testing rig. Zoe had signed a stack of non-disclosure agreements, and the legal team was still grumbling. Dr. Chen had agreed to supervise, along with 2 other senior engineers. Thomas watched as Zoe circled the engine, her eyes taking in every detail. She didn't touch anything yet, just looked, occasionally crouching down to peer at components from different angles. Can I see it run? She asked. Dr. Chen nodded to a technician, who initiated the startup sequence. The engine hummed to life. It sounded surprisingly quiet for the power it generated. On the monitors, temperature readings began to climb. How long until it overheats? Zoe asked. About 9 minutes at full power, Dr. Chen replied. Zoe pulled a small notebook from her pocket and began jotting things down. She moved around the engine as it ran, sometimes placing her hand near but not touching different components, feeling the heat radiating off them. At the 8-minute mark, she pointed to a section near the core. The heat pattern is uneven. See how this side is getting hotter faster? Dr. Chen checked the thermal imaging display. Yes, we've noticed that. We've adjusted the coolant flow to compensate, but it's not enough. Zoe shook her head. That's treating the symptom, not the cause. She looked at Thomas. Can I see the internal design, the actual parts, not just the outside? Before Thomas could answer, warning lights flashed as the engine hit critical temperature. The system automatically shut down. That's what happens every time, said one of the engineers, frustration evident in his voice. We've tried different coolant mixtures, flow rates, even modified the channel designs. Zoe waited as the engine cooled enough to be safe. I'd like to see inside, she repeated. Dr. Chen looked at Thomas, who nodded. Show her everything. For the next 2 hours, Zoe examined disassembled components, asked questions about materials and manufacturing processes, and reviewed test data. The senior engineers answered her questions with increasing respect as they realized her understanding went beyond what they'd expected. As the day drew to a close, Thomas pulled Mike aside. Your daughter is remarkable. Mike nodded, pride evident in his expression. She always has been. I wanted her to go to college, but we couldn't afford it. She's applying for scholarships now. Thomas watched Zoe deep in conversation with Dr. Chen. What if we gave her 48 hours, full access to the lab, the engineering team at her disposal? See if she can spot what we're missing? Mike looked surprised. You're serious? What about her school? We'll clear it with them. Call it an internship or independent study. We'll make it official. And if she can't solve it? Thomas shrugged. Then we're no worse off than we are now. But what if she can? Later that evening, after everyone else had gone home, Thomas sat in his office reviewing Zoe's initial notes. Her approach was unorthodox, focusing on questions the team had long since moved past. But there was a clarity to her thinking, an absence of assumptions that came with years of formal training. His phone rang. It was Robert. Have you come to your senses yet? Robert asked without preamble. We're giving her 48 hours, Thomas replied. The board will hear about this. Good. They should know we're exploring every option. This isn't about solving the problem anymore, is it? Robert's voice hardened. This is about you proving a point. Thomas thought about Harold Williams again, about the doors that had been closed to him as a young black engineer, about how one person's belief had changed the trajectory of his life. Maybe it's about both, he said finally. Good night, Robert. As he hung up, Thomas looked through the glass walls of his office to where Zoe was still in the lab, examining engine components with Dr. Chen. The young woman had no idea that the fate of a multi-million-dollar company might rest on her shoulders. All she saw was a puzzle to solve, an engine to fix. And somehow, watching her work with such focus and natural curiosity, Thomas felt something he hadn't felt in weeks. Hope. The digital clock on the lab wall showed 7:15 a.m. when Thomas arrived, the next morning. He expected to be the first one in, but the lights were already on. Zoe sat cross-legged on the floor, surrounded by engine components, papers, and half-empty coffee cups. Dr. Chen dozed in a chair nearby. Have you been here all night? Thomas asked, startling both of them. Dr. Chen jerked awake. Mr. Marshall, we were just... I couldn't sleep, Zoe interrupted, not looking up from the metal piece she was examining. Dr. Chen was kind enough to stay and supervise. Thomas noticed the dark circles under Dr. Chen's eyes. You should go home, get some rest. Dr. Chen shook her head. I'm fine. Besides, it's getting interesting. She gestured to the disassembled engine. Zoe has some unusual ideas. Zoe finally looked up. I think I know what's happening, but I need to test something. She held up a small component. This heat exchanger isn't the problem itself, but it's showing signs of stress that shouldn't be there. Thomas moved closer. What kind of stress? Microfractures, barely visible. She handed him a magnifying glass. Look at the seam here. Thomas peered through the glass and saw tiny hairline cracks in the metal. These could be manufacturing defects. That's what I thought too at first, Zoe said. But then I found the same pattern on 3 other exchangers, all in slightly different positions. She pulled out her notebook, flipping to a page with detailed sketches. The cracks always form in relation to these connection points, regardless of the unit. Dr. Chen leaned in, which suggests structural stress from operation, not manufacturing. Exactly, Zoe nodded. But here's the weird part. The stress is happening before the temperature gets high enough to cause thermal expansion. Thomas looked between them. Meaning? Something else is causing parts to shift during operation, Zoe explained. My theory is that the magnetic field from the power generation is creating enough force to cause micro-movements in these components. Dr. Chen frowned. We tested for electromagnetic interference. The shielding should prevent that. Regular shielding, yes, Zoe agreed. But what if the materials themselves are responding differently than expected, like how some metals become slightly magnetized when current flows nearby? Thomas watched as she explained her theory, using simple terms but describing complex interactions. This 17-year-old with no formal training was thinking in ways his team of PhDs hadn't considered. How do we test this? He asked. Zoe glanced. At the clock. I need about 6 hours to modify one of the heat exchangers with a different alloy. Then we can compare performance. You want to modify our prototype? Dr. Chen looked alarmed. Just one component, Zoe assured her. We can always put the original back if it doesn't work. Thomas made a quick decision. Do it. Whatever you need. Just ask. By noon, word had spread through the company that the CEO had given a teenager access to their most valuable technology. The engineering floor buzzed with speculation, some intrigued, others outraged. Robert had called an emergency board meeting for that afternoon. Thomas ignored it all, focusing instead on Zoe's progress. She worked with remarkable precision, modifying the heat exchanger with materials from the lab's inventory. Dr. Chen stayed with her, initially to supervise but increasingly to collaborate. Where did you learn to do this? Dr. Chen asked as Zoe carefully adjusted a micro-welding tool. My grandpa's shop, Zoe replied, not looking up from her work. He fixed everything from tractors to pocket watches, said small things and big things follow the same rules, just at different scales. Thomas watched from the doorway, not wanting to interrupt their flow. He'd missed this. The pure joy of problem-solving, of building something with your hands. Somewhere along the way, as he'd climbed the corporate ladder, he'd lost touch with that feeling. At 3:30 p.m., his assistant appeared at his elbow. Sir, the board is waiting. Thomas nodded. Tell them I'll be there in 5 minutes. He approached Zoe and Dr. Chen. How's it going? Almost ready for testing, Zoe said, closing a panel on the modified component. Maybe another 30 minutes. I have to step into a meeting. Can you wait to run the test until I'm back? Dr. Chen nodded. We'll get everything prepped. The boardroom fell silent as Thomas entered. 8 stern faces turned toward him. Thomas, the chairman began, Robert has raised serious concerns about your unconventional approach to our current crisis. Robert sat with his arms crossed. Letting an untrained teenager tinker with proprietary technology worth millions, it's irresponsible at best, negligent at worst. Thomas remained standing. I understand your concerns, but we've tried conventional approaches for weeks without success. Zoe has identified a potential issue our team missed. And what qualifies her to do so? Another board member asked. Results qualify her, Thomas replied simply. If her modification works, does it matter that she doesn't have a degree? Of course it matters. Robert slammed his hand on the table. We have protocols, standards. You can't just bypass years of training and experience because you have a hunch about some kid. Thomas leaned forward, placing his hands on the table. When I started this company, everyone said a black man couldn't succeed in this industry, that I lacked the right connections, the right background. His voice remained steady. I proved them wrong by delivering results. That's all I'm asking now. Judge this by results, not by appearances. The chairman adjusted his glasses. And when will we have these results? Within the hour, if you'll excuse me. Back in the lab, Zoe and Dr. Chen had the engine reassembled with the modified heat exchanger installed. Ready? Thomas asked. Zoe nodded, looking nervous for the first time. If this works, the engine should run for at least 15 minutes without overheating. Dr. Chen initiated the startup sequence. The engine hummed to life, gauges and monitors tracking its performance. A small crowd of engineers had gathered outside the glass walls of the lab, watching. 5 minutes passed. Then 10. The temperature readings, while rising, stayed below critical levels. It's working, Dr. Chen whispered as if speaking too loudly might jinx it. At 12 minutes, 3 minutes longer than their previous best, Zoe pointed to a display. Look at the vibration pattern. It's completely different. The engine continued. To run. 15 minutes, 20, no overheating, no shutdown. After 30 minutes, Dr. Chen stopped the test. That's more than 3 times our previous runtime. The room erupted in cheers. Engineers who had been skeptical now pressed forward, asking questions, examining the data. Thomas watched as Zoe explained her modification, the senior staff hanging on her every word. Later, as the excitement began to settle, Thomas found Zoe sitting alone in a quiet corner of the lab, looking exhausted but happy. "You did it," he said, sitting beside her. She shook her head. "Not completely. It's running longer, but there's still room for improvement. The efficiency could be better." Thomas laughed. "You just solved a problem that stumped our entire engineering department, and you're already looking for the next challenge." She shrugged. "That's how my grandpa taught me. Fix what's broken, then make it better than it was before." "Your grandfather sounds like a wise man." "He was." Her expression grew serious. "He passed away last year. That's partly why I'm so determined to get into engineering school. To carry on what he taught me, but with the formal education he never had the chance to get." Thomas nodded. "I understand that feeling." A commotion at the lab entrance drew their attention. The board members had arrived, led by the chairman and a still scowling Robert. "I hear we've had a breakthrough," the chairman said, surveying the disassembled engine parts. Dr. Chen stepped forward, data tablets in hand. "More than a breakthrough, a complete solution to our overheating problem." She showed them the test results. 30 minutes of continuous operation with stable temperatures. Robert studied the numbers, his expression gradually shifting from skepticism to surprise. "And this modification, it's compatible with mass production?" "Actually," Zoe said quietly, "it might make production easier. The alloy I used is more common than the original specification." The chairman turned to her. "You're the young lady who solved our problem." She nodded, suddenly self-conscious. "Impressive." He looked at Thomas. "It seems your unconventional approach paid off." Robert wasn't ready to concede. "One successful test doesn't mean we're ready for the DOE inspection. We need more data, more testing." "Of course," Thomas agreed. "But we now have a working prototype and 2 weeks to refine it." He placed a hand on Zoe's shoulder. "Thanks to Zoe." As the board members dispersed, talking excitedly among themselves, Thomas noticed Mike standing by the door. He'd come to pick up his daughter after her extraordinary day. "Your daughter just saved my company," Thomas told him. Mike smiled proudly. "That's my girl, always fixing what others can't." He lowered his voice. "Though I have to ask, what happens now?" Thomas looked across the lab where Zoe was deep in conversation with Dr. Chen and 2 other engineers, sketching something on a whiteboard. She belonged here, that much was clear. "Now," Thomas said, "we have some decisions to make. Good ones." The 2 weeks before the Department of Energy inspection passed in a blur of activity. Zoe's initial fix had proven sound, but, true to her word, she wasn't satisfied with just solving the immediate problem. Each day after school, she would arrive at Quantum Dynamics working alongside Dr. Chen and the engineering team to refine the engine further. On the morning of the inspection, Thomas found her in the lab, making final adjustments to the test rig. "Nervous?" he asked. Zoe adjusted a sensor connection. "A little. What if they don't like the changes we made?" "They'll judge based on performance, not expectations," Thomas assured her. "And thanks to you, our performance numbers are better than even we projected." This was true. The modified engine not only solved the overheating issue but now ran 15% more efficiently than the original design. The team had conducted over 50 successful test runs, each time pushing the engine harder, refining the design further. Thomas checked his watch. "They'll be here in an hour. Why don't you go get some breakfast? You've been here since dawn." Zoe shook her head. "Too nervous to eat." Dr. Chen appeared with 3 coffee cups. "Then at least have some caffeine. You'll need it." She handed cups to Thomas and Zoe before taking a sip of her own. "The team is ready. We've rehearsed the presentation twice." Thomas nodded. "And Zoe will present the modifications herself." This had been a point of contention with some board members who felt it should be Dr. Chen or another senior engineer explaining the technical details. But Thomas had insisted. Zoe had solved the problem, she should get the credit. "Just stick to what you know," he told her. "You understand this engine better than anyone now." The DOE inspection team arrived precisely on time, Three serious-looking officials in dark suits accompanied by two technical experts. Thomas led the introductions, keeping them brief, then guided everyone to the test facility where the engine waited. Dr. Chen began with an overview of the project, explaining the original design goals and the challenges they'd faced. Then she introduced Zoe. Our breakthrough came from an unexpected source, Dr. Chen said with a nod to Zoe. I'll let Ms. Reynolds explain. Zoe stepped forward, visibly nervous but composed. She explained the modification process in clear, simple terms, using everyday analogies to illustrate complex engineering concepts. The DOE officials listened attentively, occasionally exchanging glances. So in summary, Zoe concluded, the vibration patterns created by the electromagnetic field were causing micro-shifts in component alignment. By changing the alloy composition in these specific areas, we eliminated the magnetic susceptibility and created a more stable operating environment. One of the technical experts raised his hand. That's a sophisticated solution for a problem many experienced engineers might have missed. How did you identify it when others didn't? Zoe hesitated, glancing at Thomas, who nodded encouragingly. I noticed something in the way the engine vibrated, she said. It reminded me of an old steam tractor my grandfather used to work on. It had a similar issue where parts would shift slightly during operation because of resonance. Your grandfather was an engineer? The expert asked. No, sir, he ran a repair shop in rural Georgia. Fixed farm equipment mostly, some cars too. He never went to college, but he understood machines better than anyone I've ever met. Zoe's voice grew more confident. He taught me that every machine has its own voice, the way it hums, vibrates, runs. If you listen carefully, it tells you what's wrong. The room fell silent. It was an unexpectedly poetic description from someone so young, yet it resonated with the engineers in the room. Well, let's see if this machine is speaking clearly today, the lead inspector said. Shall we proceed with the test? For the next 2 hours, they put the engine through a series of increasingly demanding tests. The quantum dynamics team had prepared for most scenarios, but the DOE experts threw in some unexpected challenges: rapid power fluctuations, extreme temperature environments, unusual load patterns. Through it all, the engine performed flawlessly. The temperature readings remained stable, the efficiency metrics exceeding even their latest projections. As the final test concluded, the lead inspector removed his safety glasses. Impressive work, Mr. Marshall. Your team has exceeded the contract requirements in several key areas. Thomas smiled. Thank you, but the credit goes primarily to Zoe and Dr. Chen. They're the ones who made this happen. The inspector turned to Zoe. Young lady, you have a remarkable talent. Have you considered a career in engineering? Yes, sir. I'm applying to engineering programs for next fall. Well, any school would be lucky to have you. He turned back to Thomas. We'll need to review all the test data, of course, but I don't anticipate any issues with approval. Congratulations. As the inspection team departed, the lab erupted in cheers and applause. Engineers who had initially doubted Zoe now patted her on the back, shook her hand, some even hugged her. She had become not just accepted but respected. Thomas watched from the sidelines, feeling a deep sense of satisfaction, not just because they'd secured the contract, but because he'd taken a chance on someone who others might have overlooked. Later that afternoon, Thomas called Zoe and Mike into his office. Dr. Chen joined them along with the head of HR and, surprisingly, Robert. First, Thomas began, I want to thank you, Zoe. What you've done for this company goes beyond solving a technical problem. You've reminded us all to look beyond credentials and assumptions. Zoe blushed. I just fixed an engine. You did far more than that, Dr. Chen said. The approach you took has applications across our entire product line. We've already identified 3 other systems that could benefit from similar modifications. Thomas nodded. Which brings me to why we're here. He slid a folder across the desk to Mike. This is a scholarship offer. Full tuition for Zoe at any engineering program she chooses to attend. Mike opened the folder, his eyes widening as he read the details. This is very generous. It's not charity, Robert interjected, his earlier skepticism nowhere to be seen. It's an investment. We're also offering Zoe a paid internship position during school breaks and a guaranteed job after graduation if she wants it. There's more, Thomas continued, sliding another document forward. This is a patent application for the modification Zoe developed. We've listed her as the primary inventor, with Dr. Chen as co-inventor. Once approved, Zoe will receive a percentage of any licensing revenue. Zoe stared at the document in disbelief. You're putting my name on a patent? It's your invention, Dr. Chen said simply. Mike looked overwhelmed. I don't know what to say. Say yes, Thomas suggested with a smile. Unless you've got a better offer somewhere else? Zoe laughed, tears in her eyes. No, this is beyond anything I could have imagined. As they discussed the details, Thomas reflected on how close they had come to missing this opportunity. If he hadn't walked through the factory that evening, if he hadn't noticed Zoe, looking at those schematics, if he had listened to the doubters on his board, the company would have lost a $200 million contract, yes. But more importantly, they might never have discovered this remarkable young talent who saw problems in ways others couldn't. After Mike and Zoe left to celebrate their life-changing news, Robert lingered in Thomas's office. I owe you an apology, he said finally. I thought you were taking an unnecessary risk. Thomas leaned back in his chair. We were both right in a way. It was a risk, but sometimes the biggest risk is not taking one. Robert nodded slowly. It makes me wonder how many other Zoes are out there. People with incredible potential, but no formal pathway into our industry. Exactly. Thomas leaned forward, a new idea forming. And maybe that's something we should think about changing. The next morning, Thomas stood before his assembled staff, the successful DOE inspection behind them, a newly secured $200 million contract in hand, and announced a new initiative, one that would change not just quantum dynamics, but potentially the entire industry. And it had all started because a teenage girl noticed something in an engine that no one else could see. 6 months after the successful Department of Energy inspection, Quantum Dynamics headquarters buzzed with activity. The main conference hall had been transformed for a special event, with rows of chairs facing a small stage. Behind the podium hung a banner that read, Reynolds Innovation Program, First Class. Thomas adjusted his tie as he reviewed his speech one last time. Through the window of his office, he could see guests arriving, industry leaders, government, officials, educators, and families from the local community. A knock at his door interrupted his thoughts. Dr. Chen entered looking elegant in a formal suit instead of her usual lab coat. The press is already here, she said. And Zoe just arrived with her family. Thomas smiled. How's she doing with her college applications? She's already received early acceptance offers from MIT, Stanford, and Georgia Tech. Dr. Chen laughed. Though I'm not sure she needs college anymore. The work she's done these past 6 months would qualify as a master's thesis at most universities. This was no exaggeration. Since solving the engine crisis, Zoe had continued, working part-time at Quantum Dynamics while finishing her senior year of high school. The original engine modification had been just the beginning. She'd gone on to help redesign 3 other systems, each time bringing that same fresh perspective. Is everything ready for the announcement? Thomas asked. Dr. Chen nodded. 20 apprenticeship positions, fully funded. The selection committee has reviewed over 500 applications. And how many of them look like traditional engineering candidates? Very few, Dr. Chen admitted. We have mechanics, hobbyists, people who repair appliances, a watch restoration expert, 2 former military equipment technicians. Perfect, Thomas said, and that's exactly what we want. The Reynolds Innovation Program had been Thomas's brainchild, inspired by Zoe's success. Its purpose was simple but revolutionary. Find talented people with hands-on mechanical aptitude, but no formal engineering education, and pair them with senior engineers in a 2-year paid apprenticeship. The apprentices would gain technical knowledge and theoretical understanding, while the engineers would benefit from the apprentices' practical insights and fresh perspectives. The program had initially faced resistance both within the company and across the industry, Many argued that it devalued formal education and would lower standards. Others saw it as a publicity stunt. Robert had been among the skeptics until Thomas had shown him the numbers. In the 6 months since implementing just a few of Zoe's innovations, Quantum Dynamics had seen productivity increase by 22% and warranty claims decrease by 17%. The financial projections for the coming year showed potential record profits. "It's time," Dr. Chen said, checking her watch. Thomas took a deep breath and followed her to the conference hall. As they entered, the buzz of conversation subsided. The room was packed, every seat filled with additional guests standing along the walls. In the front row sat Mike and his wife, dressed in their Sunday best, pride evident on their faces. Beside them was Zoe, looking both excited and slightly embarrassed by all the attention. Thomas took the stage, adjusting the microphone. "Good afternoon, everyone. Thank you for joining us for this special occasion." He scanned the audience, noting the mix of faces, young and old, representing diverse backgrounds and experiences. 6 months ago, Quantum Dynamics faced a crisis. Our revolutionary engine design, the cornerstone of a $200 million government contract, had a critical flaw that our top engineers couldn't solve. He paused, letting the tension of that moment sink in. We had tried everything by the book, every standard approach, every conventional solution. Thomas gestured to Zoe. And then, by chance, I noticed a 17-year-old girl looking at some old schematics during her lunch break. She was visiting her father, one of our machine operators. Something she said caught my attention, a simple observation that our experts had overlooked. He recounted the story of Zoe's unconventional approach and remarkable solution, drawing laughs when he described the board's initial skepticism and applause when he revealed the successful DOE inspection. But this isn't just a story about one talented young woman, Thomas continued. It's about what happens when we look beyond traditional credentials and recognize that brilliance comes in many forms. He motioned to Dr. Chen, who unveiled a large screen displaying photos of people in workshops, garages, and repair shops. These are some of the first participants in our new Reynolds Innovation Program, named in honor of Zoe and her grandfather, whose practical wisdom sparked this journey. Thomas looked directly at Zoe. People with extraordinary hands-on talents but who might never have found their way into engineering through conventional paths. The screen changed to show the new training facility being built on the Quantum Dynamics campus. Starting next month, these 20 apprentices will work alongside our senior engineers, bringing together practical experience and theoretical knowledge in ways that will transform not just our company, but potentially our entire industry. Thomas then invited Zoe to join him on stage. The audience erupted in applause as she made her way forward, blushing slightly at the attention. Zoe's story reminds us that innovation often comes from unexpected sources, Thomas said. Her grandfather never had the opportunity for formal engineering education, but he passed down generations of practical knowledge that proved invaluable. Zoe stepped to the microphone. "My grandpa used to say that books can teach you the rules, but your hands teach you the exceptions." Her voice was soft but steady. "Everything I know about fixing things came from working beside him in his shop, seeing how machines actually behave in the real world, not just how they're supposed to work in theory." She looked out at the audience. "I'm honored by this program, and the opportunity it will give to people like me, who learn by doing, by taking things apart and putting them back together." As Zoe returned to her seat, Thomas introduced the program's first class of apprentices, who stood to thunderous applause. They ranged in age from 19 to 63, came from diverse backgrounds and shared one common trait: extraordinary mechanical intuition developed through years of hands-on experience. After the ceremony, as guests mingled during the reception, Thomas found himself approached by a representative from a major engineering university. "Remarkable initiative, Mr. Marshall," the woman said. "We're interested in discussing how this apprenticeship model might be incorporated into our curriculum. Perhaps a pilot program?" Before Thomas could respond, the president of a competing engineering firm joined them. "I was skeptical when I heard about this," he admitted. "But after seeing the results and meeting these apprentices, well, we might need to rethink our own hiring practices." Throughout the evening, similar conversations took place. What had begun as one company's innovative solution was sparking interest across the industry. Trade publications had sent reporters. Educational institutions were taking note. Government agencies were considering similar approaches for their technical positions. Later, as the event wound down, Thomas found Zoe and her parents preparing to leave. "Quite a day," Mike said, shaking Thomas's hand. "When I brought Zoe to visit me at work that day, I never imagined all this." Thomas smiled. "Neither did I. But that's how the best innovations happen, when we're open to seeing possibilities where others see problems." Zoe looked thoughtful. "My grandpa would have loved this. He always said knowledge should flow in both directions, from books to hands and from hands to books." "Wise man," Thomas nodded. "And speaking of flow, the patent office approved your design this morning. The licensing agreements are already being negotiated with 3 major manufacturers." Zoe's eyes widened. "Really? Really? Your college fund just got a significant boost." Thomas handed her an envelope. "The official notification and your first royalty check." As Zoe and her parents left, visibly emotional, Robert approached Thomas, with a tablet displaying the evening news. "We're trending," he said, showing Thomas the headlines. "Quantum Dynamics launches revolutionary apprenticeship program," and "Teen engineer changes industry paradigm." Thomas scanned the articles. "They're focusing on the human angle." "Of course they are," Robert said. "It's a great story. The black CEO who took a chance on a teenage girl with no formal training, changing the face of an industry known for its rigid credentials." He shook his head. "You couldn't have planned this better if you tried." "I didn't plan it at all," Thomas reminded him. "I just saw a problem and was willing to look for solutions in unexpected places." Later that night, alone in his office, Thomas reflected on the journey of the past 6 months. The crisis that had threatened to sink his company had instead transformed it into something stronger, more innovative, and more inclusive. On his desk sat a small framed photo taken the day of the DOE inspection. Zoe standing proudly beside the engine she had fixed, her future bright with possibilities she had never imagined possible. Next to it was a list of the first 20 apprentices in the Reynolds Innovation Program, each with a unique story, each with untapped potential that might otherwise have gone unrecognized. Thomas thought about Harold Williams, the man who had given him a chance decades ago when others wouldn't. How that single act of faith had created ripples that continued to spread, touching lives far beyond what either of them could have foreseen. He picked up his pen and began to write a letter to Zoe's grandfather. The man might be gone, but his legacy lived on in his granddaughter and now in this program that would open doors for countless others. "Your hands taught her the exceptions," Thomas wrote, "and now she's teaching us all."